For more than a century, cars have required one thing: a driver. Now imagine a car built with no steering wheel, no pedals, no human driver required. And imagine that car costs $30,000. Tesla's Cybercab is no longer just a concept on stage. Production activity at Giga Texas appears to be accelerating. And that raises a serious question. Is Tesla actually preparing to mass-produce a $30,000 fully autonomous robotaxi? Or is this another ambitious target that will take longer than expected? Because if Cybercab reaches scale at that price, it does not just compete with other electric vehicles. It challenges ride-sharing, taxi fleets, and even private car ownership itself. Today we are breaking down what production surge at Giga Texas really means, whether $30,000 is financially realistic, and how Cybercab could reshape transportation economics. If you want serious Tesla analysis focused on scale, manufacturing, and economic impact, subscribe to the channel right now. We look beyond headlines and examine the real numbers. Because autonomy is not about marketing, it is about math. Let us begin.
What does production surge actually mean?
Now let us slow down and define something very carefully. When people say Cybercab production is surging at Giga Texas, what does that actually mean? Because in Tesla language, there are stages: prototype stage, pilot production, pre-production ramp, true mass production. Those are very different phases. 1. Giga Texas expansion signals. Recent activity at Giga Texas suggests dedicated space allocation for next-generation platform, reconfigured assembly zones, structural casting capacity expansion, automation upgrades for faster throughput. If Cybercab uses Giga casting for front and rear sections, plus structural battery integration, Tesla can reduce part count dramatically. Fewer parts means faster assembly, lower labor cost, fewer failure points, higher scalability. That is the foundation for any $30,000 vehicle. Without radical simplification, that price is impossible. 2. The unboxed manufacturing factor. Tesla has repeatedly hinted at a new, unboxed production method. Instead of building a car sequentially on a long traditional line, major modules are built in parallel and combined at the end. For a vehicle like Cybercab, which removes steering system, pedal assemblies, traditional dashboard complexity, manufacturing becomes even simpler. Less hardware equals lower material cost, lower assembly time, fewer suppliers, reduced logistical friction. That is how cost compression begins. 3. But surge does not mean millions yet. Here is the reality. A production surge can mean hundreds of units, thousands of units, or simply rapid ramp preparation. True mass production would mean tens of thousands per quarter. We are likely still in ramp phase. And ramp phase is about quality control, battery supply alignment, software validation, autonomy performance stabilization. Autonomy must be extremely reliable before scaling widely. Because robotaxi failure risk is not just mechanical, it is reputational. Now here is the big question. Even if Tesla can produce Cybercab efficiently, can it really hit $30,000 at scale? Before we move into the cost breakdown, take a moment to subscribe if you have not already. The next section is where we run the financial math behind the $30,000 claim.
Is $30,000 financially possible?
Now we reach the heart of the headline. $30,000 for a fully autonomous robotaxi. No steering wheel, no pedals, full self-driving hardware. At first glance, that sounds aggressive. So let us break it down logically. 1. Removing driver hardware lowers cost. Cybercab eliminates steering column, steering rack, pedal assembly, traditional instrument cluster, complex dashboard controls. That removes mechanical components and wiring. Less hardware means lower material cost, faster assembly, fewer suppliers, reduced warranty exposure. Every removed system compresses cost. 2. Mega casting plus structural battery advantage. If Cybercab uses front gigacast, rear gigacast, structural battery pack, Tesla dramatically reduces part count. Instead of hundreds of welded components, large cast structures replace them. Fewer parts equals lower labor time, lower defect rate, lower manufacturing variability. That is how Tesla reduces cost per unit at scale. But cost reduction depends heavily on volume. 3. Battery cost is the critical variable. The biggest cost in any electric vehicle is the battery. If Cybercab uses LFP chemistry and Tesla continues improving 4680 production efficiency, battery cost per kilowatt hour could fall significantly over the next few years. At high volume production, battery pack cost could become manageable within a $30,000 vehicle target. However, this requires high-yield 4680 manufacturing, stable raw material sourcing, massive production scale. Without battery cost compression, $30,000 becomes difficult. 4. Autonomy hardware cost. Cybercab must include multiple high-resolution cameras, advanced AI compute hardware, redundant safety systems. Tesla's advantage is vertical integration. Instead of buying third-party autonomy systems, Tesla designs its own AI chips. That reduces supplier markup. But autonomy hardware is still not free. The cost must be amortized over high production volume. 5. The profit model may not be traditional. Here is something many people miss. Tesla may not rely on vehicle margin alone. If Cybercab generates revenue through autonomous ride networks, Tesla could accept lower upfront margins. In that model, lower vehicle price increases fleet adoption. Autonomous network generates recurring revenue. Software becomes profit center. That changes pricing strategy completely. $30,000 becomes more realistic if revenue continues after sale. Now pause for a moment. If Tesla produces Cybercab at massive scale, simplifies hardware, reduces battery cost, and monetizes autonomy through network revenue, $30,000 stops sounding impossible. It starts sounding strategic. Before we move into the autonomy risk and regulatory challenge, make sure you are subscribed. The next section will address whether full autonomy is ready for this kind of scaling.
Is full autonomy ready for mass scale?
Now we reach the most sensitive part of this entire discussion. Autonomy. Because Cybercab only makes sense at $30,000 if it truly drives itself reliably. Not almost. Not sometimes. Reliably. 1. Supervised versus unsupervised reality. Tesla's current full self-driving system operates in supervised mode. That means human driver remains responsible. Human intervention is still required in complex scenarios. Legal responsibility stays with the driver. Cybercab changes that completely. There is no steering wheel, no pedals, no fallback human driver. That means autonomy must reach a much higher reliability threshold. This is not incremental. This is structural. 2. The safety threshold. For Robotaxi scale, Tesla must prove low accident rate compared to human drivers, stable performance in urban environments, reliable handling of edge cases, strong redundancy systems. Edge cases are the challenge. Construction zones, unexpected obstacles, unpredictable pedestrians, severe weather conditions. Autonomy must handle all of them consistently. One high-profile failure can slow regulatory momentum significantly. 3. Regulatory approval is the gatekeeper. Even if the technology performs well, regulatory bodies determine deployment scale. Each state and country has its own framework for autonomous vehicles. Large-scale robotaxi deployment requires government approvals, safety validation, legal liability frameworks, insurance adaptation. Tesla can build cars quickly. Regulatory approval moves slower. This may be the true pacing factor. 4. AI compute advantage. Tesla's advantage is data. Millions of vehicles collecting driving data daily. That creates massive neural network training inputs, continuous improvement cycles, faster iteration. Cybercab benefits from the same AI training ecosystem used in consumer vehicles. If Tesla continues accelerating AI compute performance, autonomy capability improves over time. But scaling from supervised to unsupervised is not a minor upgrade. It is a leap. Now ask yourself this carefully. If autonomy is 95% reliable, is that enough for a steering wheel-free vehicle? Or does it need to be 99.9%? The margin matters, because trust drives adoption. Before we move into the economic disruption potential of a successful $30,000 robotaxi, make sure you are subscribed. The next section will explore what happens to ride-sharing, taxis, and even personal car ownership if Cybercab scales successfully.
If $30,000 is real, what happens next?
Now let us assume something very important. Let us assume Tesla succeeds. Let us assume Cybercab reaches true autonomy. Production scales at Giga Texas. $30,000 becomes real. What happens next? Because the disruption would not be small. It would be structural. 1. Ride-sharing economics change overnight. Today, ride-sharing companies depend on human drivers. Human drivers require income, incentives, flexible hours, surge pricing. A robotaxi fleet removes the driver cost entirely. Driver compensation is often the largest cost in ride-sharing. Remove that cost, and suddenly, ride prices can drop, margins can increase, utilization can rise. A cybercab operating 20 hours per day generates far more revenue than a privately owned vehicle parked 95% of the time. That is the leverage. 2. Private car ownership gets questioned. If a $30,000 autonomous vehicle can pick you up, drop you off, return home, operate without human input, then ownership becomes optional for many urban residents. Instead of buying a car, some people may subscribe to a robotaxi network. Lower parking demand, lower congestion in certain areas, shift in insurance models. This is not about replacing every car. It is about replacing certain use cases. 3. Fleet operators move fast. If the math works, fleet operators will move quickly. Imagine logistics companies, rental companies, urban mobility providers, all analyzing cost per mile and utilization rate. If Cybercab produces steady revenue per mile with minimal downtime, capital flows into fleets rapidly. That is how disruption accelerates. Not through headlines, through spreadsheets. 4. The risk factor. But let us stay grounded. For this to work, autonomy must be trusted. Regulation must allow deployment. Insurance must adapt. Public acceptance must grow. A single widely publicized incident could slow rollout. Trust builds slowly. Disruption accelerates once trust stabilizes. Now pause for a moment. If Cybercab truly reaches $30,000 and autonomy becomes reliable, the biggest shift will not be technological. It will be behavioral. People will rethink transportation itself. Before we conclude, take a moment to subscribe if you have not already. The final chapter will answer the core question directly. Is $30,000 realistic, or is it strategic optimism? So, is $30,000 real, or just hype? Now we answer the core question directly. Is a $30,000 fully autonomous cybercab realistic, or is it another ambitious projection? The honest answer is this. $30,000 is possible, but only under very specific conditions. The conditions required. For $30,000 to become real, Tesla must achieve high-volume giga casting efficiency, mature 4680 battery cost reduction, scaled unboxed production, fully validated unsupervised autonomy, regulatory approval for commercial deployment. If even one of these elements stalls, pricing pressure increases. This is not a simple vehicle launch. This is an ecosystem launch. The strategic pricing angle. Tesla does not need Cybercab to behave like a normal consumer vehicle. If Cybercab operates inside a revenue-generating robotaxi network, pricing logic changes. A fleet owner will calculate cost per mile, utilization rate, revenue per day, payback period. If a $30,000 Cybercab generates steady income, the purchase price becomes easier to justify. In that model, Tesla can price aggressively to accelerate adoption. Lower margin per unit, higher network scale, recurring software revenue. That is long-term strategy. The risk layer. However, there are risks. Autonomy must prove extremely reliable. Regulation must align. Public trust must grow. Battery scaling must remain stable. If any of these factors lag, timeline shifts. $30,000 may arrive later than expected, but the direction appears intentional. The bigger picture. Cybercab is not just about building a cheaper Tesla. It is about redefining transportation economics. If Tesla successfully combines mass production surge at Giga Texas, structural manufacturing simplification, AI autonomy scaling, ecosystem monetization, then $30,000 stops sounding impossible. It starts sounding strategic. The real question is not whether Tesla can build one. The real question is whether Tesla can build hundreds of thousands profitably. That is the tipping point. Now I want your honest take. Do you believe $30,000 for a fully autonomous Cybercab is realistic within the next few years? Or do you think autonomy will delay that target? Comment below and share your perspective. If you want grounded analysis of Tesla production ramps, autonomy economics, and long-term strategy, subscribe and turn on notifications so you do not miss our next deep dive. And in the next video, we will analyze whether Tesla's Robotaxi network could eventually generate more revenue than vehicle sales themselves. Thank you for watching. Think scale. Think economics. And I will see you in the next one.